Hello guys, I'm going to discuss all about backpatching. This is my topic about the compiler. So let's proceed. The main problem in generating three address codes in a single pass for Boolean expressions and flow of control statements is that we may not know the labels that control must go to at the time jump statements are generated. This problem is solved by generating a series of branch statements with the targets of the jumps temporarily left unspecified. Each such statement will be put on a list of goto statements whose labels will be filled in when the proper label can be determined. Then, this subsequent filling of addresses for the determined labels is called backpatching. Our main focus about backpatching. So, ito dapat atong pagfokusan. For implementing backpatching, we generate quadruples into a quadruple. So, let us specify, or we can call this compress array, and labels are indices to this array. So to manipulate list of if labels, we have three functions. Make list I, second one merge p1 p2, and backpatch pi. Make list I, it creates a new list containing only I, an index into the array of quadruples, and returns pointer to the list it has made. So that we call this make list. So then merge ij concatenates the list pointed to by I and j variables, and returns a pointer to the concatenated list. So that's it, Then backpatch pi inserts I as the target label. So I is the target label for each of the statements on the list pointed to by p. So that's the backpatch function. Now let's try to construct the translation scheme for Boolean expression. Let's the grammar be E is E1 or im E2. Then E1 and M2, then not E1, then inside the parenthesis E1, then ID1 real O, ID2, it's the identifier, then relational operator, the identifier again. So E is false, then E turns to true, then M can be an empty. So that's it. Then let's proceed. What we have done is inserting a marker non-terminal M. So it's not it's non-terminal M into the grammar to cause a semantic action to pick up at appropriate times the index of the next quadruple to be generated. This is done by the semantic action M quad is equals to next quad for the rule M is empty. So that's it. We have tackled from earlier the quadruples turn to quadruple. So that's it, to synthesize attributes, true list and false list of non-terminal E are used to generate jumping code for Boolean expressions. So what is it? So E, true list. So it contains the list of all the jump statements left incomplete to be filled by the label for the start the code for E equals to true. So that's it, the true list. Then a false list. It contains the list of all the jump statements left incomplete to be filled by the label for the start of the code for E is equals to false. So that's the false list. Then the variable next quad holds the index of the next quadruple to follow. this value will be backpatched onto E1 true list in case of E turns to E1 and in E2, where it contains the address of the first statement of E2 code. So further, this value will be backpatched onto E1 false list in case of E is E1 or ME2, where it contains the address of the first statement of E2 code. So then let's proceed. We use the following semantic action for the above grammar. Once E turns to E1 or E2. So let's backpatch E1 false list M quad. Then we have E true list merge E1 true list, E2 true list, and E false list, E2 false list. So we have used there a function that we've tackled earlier, the backpatch, then the merge, and the other is that let's go to 2 E turn or is E1 and ME2 backpatch again E1 true list M quad. So we have E true list, E2 true list, E false list equals to merge E1 false list, E2 false list. So it's like grabbing it's a container that you must fill it with that can be contained. Yeah. It's version 3 E, not E1, then E true list equals to E1 false list, and E false list is equals to E1 true list. It's like vice versa as we can see. Okay, let's proceed. E, then because parent inside of it is an E1, open and close parent. Then E true list, it's like proportion, we call this E1 true list also is similar to itself, so like also in false list. Then it's the 5 E ID 1 real operation ID 2. So we have E true list is equal to make list next quad. Then we have first list, we have make list next quad plus 1. So it's like it's you must follow it requirements. So we have emit if ID1 place real operator, ID2 place go to blank, emit go to blank. So what is the blank? What's its purpose? So E turns to true, E true list plus a make list next quad emit go to, it's like something is missing that, so go to somewhere else. So E is equals to false, E false list make is equals to make list next quad emit go to blank, then M is empty, then M quad next quad go to some statement in the blank, so you can put the statement there in the spaces must provide. So that's it, we call that backpatching. Then let's go back to the main purpose. This subsequent filling of address for the determined label is called backpatching. So thank you for listening. I hope you appreciate it. Well, thank you again.